All right, welcome to my week 2 video explainers. This problem is going to be just one of the practice problems, not one for credit. So we are told that in the classical model of the hydrogen atom, the electron orbits the proton in a circular orbit of radius 0.053 nanometers, and we're trying to find the orbital frequency. And it's also noted that the proton is so much more massive than the electron that we can assume that the proton is at rest. So first, just a couple things that we know is the radius of the orbit, which is 0.053 nanometers, or 0.053 times 10 to the negative 9 meters. And we also know the charge of an electron and the charge of a proton. So to find the electric force between the proton and the electron, we can use Coulomb's law. So that's going to be 1 over 4 pi epsilon naught times I kind of messed up there, but those charges should be absolute values. So it's just going to be that 1.6 times 10 to the negative 19th value squared over that radius of orbit, 0.053 times 10 to the negative 9th squared. So for the electric force between the proton and electron, it is found to be 8.202 times 10 to the negative 8th newtons. And now, the force needed for an electron to move around the proton, we can find that with the force equals mass times velocity squared over r. And to put it in terms of frequency, if we move around some of the variables, we can find that we can do the mass times the radius over 2 times 2 pi over t squared. And now that we have that, we know that the mass is going to be 9.1 times 10 to the negative 31 kilograms. That radius is the radius of orbit, which we were given, which is 0.053 times 10 to the negative 9 meters. And then that 2 pi squared effectively turns into 4 pi squared. And now, and also we use the force between an electron and a proton to ultimately isolate for that t period, which is going to turn out to be 1.524 times 10 to the negative 16th seconds. And to get the orbital frequency, it's going to be 1 over the period, which is going to be 6.56 times 10 to the 15th revolutions per second. So yeah, this is just a good combination regarding Coulomb's law, but also frequencies. So yeah, thank you.